Okay, so we will talk about the key management right now, and it is based on the principles of information security, 6th edition by Whitman and Medord. And what is the definition of key management, or what is key basically? It refers to the process and technique used to generate, distribute, store, use, rotate, and destroy cryptographic keys securely, right? So the keys which are used for like public key and private key, used for encryption or decryption, and the process of basically generating these keys, distributing these keys means classifying them as public or private, storing them, using them, rotating them means we can also change their mathematical representation, and we can destroy them as well. It is a fundamental aspect of cryptography and ensures that encryption remains effective. Okay, boring stuff. Effective key management is crucial because poorly handled keys can compromise an entire security system, right? So there's a lot of talk about whether the key should be small or the keys should be large, and we talked about the RSA and the ECC, right? The elliptic curve cryptography. They have different difference in them, and one of the difference is the key length, and not the key length is same, but the difference is in the way they use these keys. So ECC is more efficient with the same key length, but RSA is less efficient with the same key length. So it depends upon the efficiency that how can we really securely use those keys to kind of make sure that both work correctly, right? Now we have the life cycle of a cryptographic key. So, right, so first of all we generate the key, creating cryptographic keys using secure algorithms. So we'll first do our generation, then we will do a distribution where we securely share keys with authorized parties. We will store that key, storing keys in a safe environment, preventing unauthorized access. Key usage, using keys for encryption, decryption, signing, and verification, as we normally do. Key rotation, periodically changing keys to reduce risk exposure. Means there are some periods or there are some fixed amount of intervals where we are changing keys for some fixed word, right? So if I have a person signing to my side and I give some password to them and some key some key associated with them, then I can change those keys to kind of authenticate the same person so that I may be sure that it's the same person and we don't have any attacker or someone else. So rotation means periodically changing the keys to reduce risk exposure, because when we're changing keys, there's less risk that someone will be able to guess it. Key revocation, making a key as no longer valid due to compromise of expiration. So if something happened bad, or maybe the keys expired, they have of course the time limits for which they are going to be valid, and so that's why we use this compromise expiration thing. Key destruction means we securely delete the keys after the use period to prevent unauthorized recovery, so that someone cannot use it. And this can happen because if someone can recover the key, they may inject it to our system, which may not be able to recognize that it is not valid, because the system has worked with the same key before, so it will think probably that the system is really going well. So this can also manipulate your system. So first of all, we have generation. So what I'm just talking about system here is any type where you use cryptography, right? In web, in your own apps, or for authentication, etc., etc. So we have 7 steps in the key lifecycle. We have a generation, distribution, we have a storage, we have a usage, then we have rotation. The revocation means it should be no longer valid. It's not really in the words, that's what I should tell you. Key destruction means just destroy it. Generation, I can make a small generation. Distribution, storage, usage, rotation, revocation, D. Right, so this is a small abbreviation. If you want to kind of, DD, SURD, right? It's more easy to learn abbreviations than to learn the whole word. So simply a GD first, and then us, sorry, not us, but SU, Sue, and then a double R and D. So I will talk about them. I will ask you in the next video about these, so if you remember them. So we have generation, destruction, storage, usability, usage, whatever, rotation, revocation, and destruction. So GD, SURRD, right? Example of key management could be scenario banking transactions. For example, a bank encrypts customer data using AES. The encryption keys are rotated every 90 days for security, right? So they encrypt data how? We talked about they encrypt the data using keys, encrypted keys, and the encrypted keys are going to be changed for every 90 days. They are going to be revocated. Keys are stored in a hardware security module to prevent theft. We have studied about that. Keys could be stolen, so that's why it's important to put it in a hardware security module. When a key reaches its expiration, it is securely deleted and replaced. Right. So two important things here: that the encryption keys are rotated every 90 days and they are stored in hardware security module. Real-world examples of key management: transport layer security. For example, websites use TLS certificates to encrypt traffic. Keys are stored securely, rotated, and revoked when compromised. Right. So in the transport layer security, and for the secure socket layer, we use the key management. Cloud key management services. AWS means Amazon Web Services. KMS, Google Cloud KMS means the key management system. And Azure Key Vault manage encryption keys securely. For example, a company storing customer data on Google Cloud uses Cloud KMS to encrypt and rotate keys automatically. It means each company has their own key management system, and if some company is using their management system to protect to place their data, they will also protect their data using their company system, prevention of key system. Okay, cloud key management systems, we have AWS, Google, and Azure. End-to-end encrypting apps like WhatsApp and Signal, and session keys expire after a period of security, right? And it generates the encryption keys. There are very fancy math involved. Blockchain and cryptocurrency. Bitcoin wallets use private keys to sign transactions. Cold wallets store keys offline to prevent hacking. So Bitcoin wallets are, the ones which the Bitcoin coin. Maybe you have heard about it. These are the wallets which use the private keys to sign transactions, and the cold wallets are storing keys offline so that they could prevent hacking. And there are some challenges to it. The challenges that it could be key theft. Maybe someone stole the key. So in this case, it should be stored in hardware security module. Maybe the key is lost. Implement key recovery mechanisms. So in the software, key lost means that maybe you have stored your key somewhere and now you can't track it. So now you lost your real key. Key distribution, use asymmetric encryption like RSA for secure key exchange. Key expiry and rotation, use automated key rotation policies. Quantum threats, develop post-quantum cryptographic key management, right? So if quantum is making you threat, just make your key management systems according to the quantum, right? So key distribution means what do you say? Which one should be the private key? Which one should be the public key? So it's better to use RSA or some other, algorithm that can do it really efficiently. Key expiry and rotation, you should have automated rotation principles so that you don't have to do these things yourself, because there's more chance of attack in manually doing it. So automated key rotation policies. We have a diagram representation. We have a key generation. We use AES or RSA or ECC. Apart from DES, everything is quite. Every time we talked about these keys, we will always come up with these algorithms, unless quantum take over that. Key distribution, security sent using asymmetric encryption. Key storage stored in. So we talked about GD, URR, D. What am I missing? I'm missing S here. Okay, they're just here. Good. So this was our kind of the abbreviation we talked about: generation, distribution, storage, usability or usage, rotation, revocation, and destruction. And then we store them in HMS like hardware security modules or cloud management systems. Then we use for encryption, signing, and authentication. Then we rotate them, periodic renewal to minimize risk. We periodic rotate them and we renew them. Then we have revocation, marked invalid if compromised or expired. Key destruction, securely wiped from storage. This was a whole cycle. Modern applications. Zero Trust security. Organizations use strict key access policies to prevent inside threats. Multi-party completion. In using blockchain wallets to distribute private keys securely. So multi-party computation is used in blockchains to distribute the keys properly. It's also a system. Post-quantum cryptography. Key management strategies are evolving for quantum safe encryption. As you know, the quantum computers and quantum things are coming up, there are chances that more encrypted, technologies will also come up to encrypt data efficiently. So we have now zero trust security here, and we have multi-party computation, where we distribute the private keys securely. So this was key management. In the next one, we will study vulnerabilities and protections in information security.